So morning students, once again, hope you're all well. Welcome to this lesson for database concurrency. And first of all, I hope that you did well in your exams. You'll have your results very soon. Now, the reason why I'm doing this pre-recorded video is because we realized that the big blue button, okay, it's a very good tool, but those recordings which we usually leave on the site have made the site to be a bit less efficient. That's why sometimes last week during the exam, the site crashed because of the capacity. It had reached its full load capacity, hence it could not be able to contain all the activities that were happening there. And realized that one of the issues was the big blue recording buttons for the live sessions, which we have to remove them, and we share links with them. So me, I had the option of either using Big Blue or Zoom, but I decided that I'll use Zoom so that it will be a precursor to the unit, so that for most of those students who might not be able to attend this class, I know some of you are locked out due to the fee issue, that you can, I'll leave the link, which you can find the video on YouTube, which will be very helpful in the days that are coming. So we have discussed a lot of aspects in database concurrency, and we had reached up to the point of where we talked about the need for concurrency, database concurrency. I talked about serializability in the database, and we defined those concepts about serializability and the need for recovery in a database management system, and the attributes, desirable attributes of a transaction in a DBMS, and all of that. And we explained that in the concurrency part 2 video. So, and then we did the cut, which I believe most of you have gotten their marks. Although, save for the fact that some of you decided to be a bit cheeky and share, and I don't know how you guys do it, but posting the same information, even handwriting, even diagrams, the way diagrams are drawn, you're finding 3 or 4 people having the same type of diagram, which is very bad. You know, even if you're doing things online, kindly try as much as possible to do your own stuff, so that as much as it is just a cut which you can be able to copy from another person, some of these things you might be asked for in a practical kind of an interview setting. So I believe it's really important that you students take this thing seriously, so that it does not come and bite you in the face one day. So today we are going to talk about database concurrency implementation. And the first thing we are going to look at is lock-based protocols. Now, database and concurrency implementation, we're going to look at methods that are used to ensure that we have concurrency in a database. And we saw that there is need for concurrency so that we could not have issues like the lost update, not have issues like phantom reads and all of that. So that's why we need to have these aspects of ensuring that we have these concurrency methods implemented. And the first one is what you call lock-based protocols, implementation of locking. Okay, so lock-based is the first method that is used to ensure that we have concurrency in a database. So that's the first one. Lock-based protocols. Let me just then I put this lock-based protocols. That's the first thing which we use to ensure that we implement concurrency in a database. So that's the first method that we have to do, locking. And locking basically usually like telling students that most of these things we get them, most of the terms that we talk about, we get them from things we use in our day-to-day lives. Locking, I lock you, lock. Watu wengine wanasema kutoa lock. I don't know kutoa lock ni nini, okay? Ni kama unakunywa pombe watu wanajua kutoa lock. So lock-based, when something is locked, it means that it is locked for that particular duration of time to be used by that particular person or transaction. That's why it's called a lock-based protocol. So multiple transactions may request a lock on an item, on a data item simultaneously. Hence, there is requirement for a mechanism. There is need for a mechanism to control these locks because of serializability and multiple access. Same data item by various transactions. That's what we might be looking at. So there's that need. We need to have that concurrency, need for controlling the locks, and the need to ensure that these aspects are controlled in an efficient and effective manner. Now, for a database to control these transactions, it does this through what we call, it achieves this through what we call the lock manager. So there is a device, or because it's a system, so we cannot say it's a device. There is a protocol inside the system, inside the database management system, that is called the lock-based manager. And this lock-based manager is the one that shall be used to control access, simultaneous access to this database transaction by these various aspects that we have in a database. Now, so if we have a lock-based manager, then it means that we should be able to ensure that we do not deny access to other transactions to prevent incorrect results. Now, that's locking. Now we have two types of locks. We have two types of locks. We have two types of locks. The first lock is what we call the shared lock. Shared lock. And the second one is what we call the exclusive lock. So you have those two types of lock, shared lock and exclusive lock. We have those two types of locks, shared and exclusive. Shared and exclusive. Now, sometimes you can go and find that in some other aspects, like in some other books. You can have things we call. Okay, we have shared and exclusive locks, and then we have. Sorry about that. Yeah, that's what I'm saying. In some other books, you can go and find that we have a third lock called binary. And have another lock we call a binary lock. Now, the funny thing is that in some books, you can find that shared and exclusive are considered as one type of lock. And then we have binary lock. But in these cases, the most important thing to remember is that we have those types of lock: shared, exclusive, and binary lock. Now, shared lock is basically what we call a read lock. Shared lock is what we call a read lock. And remember, we say that in a database, we have types of transactions. We have two types of transactions, or two types of functions you can do in a database. You can read and write. So shared lock is basically a read lock, while exclusive lock is basically a write lock. Right? Lock. So now you can be given a shared lock, meaning that you can only read that database item, and you cannot write. Or you can be given an exclusive lock. When you're given an exclusive lock, it basically means that you're also given the read, the read writes and everything. And then you have the binary lock. Binary lock is a lock which incorporates both two states, that is the unlocked and the locked state of a database. So meaning that a binary lock now uses both. It uses shared and exclusive lock. So that is what we have to do. Now, when you're looking at these locks, let me look at these types of locks. I've explained those two. Those are the two types of locks you can have. Now, read lock, when we talk about the shared lock, the read lock allows several transactions to read a certain element in a database simultaneously, but no transactions can change it at the same time, while write lock allows one transaction exclusive access to write to a resource. No other resource can read this aspect. So that's the difference you have to understand with a read lock. So with read lock, you can have several transactions accessing the data item at the same time to read the resource. But no transaction can change it. No transaction can change the resource at the same time. So that's a read lock. So you have to remember that read lock, munaweza soma. You can read anything that is in there. Like for example, like right now, if I was to give you a read lock, everyone could be able to access the materials and do anything with them at that time. But you cannot be able to edit at the same time. So that's a read lock. While lock usually denoted as X. It's usually denoted as W, not X, as W, because read is R and write is X. A write lock allows one transaction exclusive access. Allows one transaction exclusive access to a data item while performing a write operation. That is another thing which you have to understand. So with shared and read lock, it means that if you have a shared lock, it means that you can read. So many of you can read it. But there's usually a certain aspect in a shared lock which ensures that you do not have rights to write into that data item. You're just basically reading, you're viewing, but you cannot edit, you cannot manage anything. But with exclusive, it means that you have exclusive access to that data item for a particular period of time so as to perform those aspects that we are having. So we have that shared and exclusive. Now, so one thing that we have to ensure, that one thing that we have to know is that with the shared and exclusive law, they were brought about shared and exclusive lock were brought about to mitigate the issues brought about by the binary lock. to get the issues brought about by the binary lock. So first of all, you have to ask yourself, what was the binary lock doing? Okay. One thing with the binary lock we have to ensure is that you see with the binary lock, it incorporates two states, that is unlocked and the locked state. Now, one thing with the binary lock is that binary lock led to something we call deadlocks. Binary locks led to deadlocks in a database. Why do we say it led to deadlocks? Because the way a binary lock functions, is that with a binary lock, is that it usually used to lock a data item with each database item, so that if the database item is 1, then it means it's unlocked. If it's 0, then it means it's locked. So they're usually associated with deadlocks. Why? So in a binary lock, what it usually happens is that when locking a database item, because you don't lock a transaction, you lock a database item. Remember that. You lock a certain record or you lock a certain table to be used by that transaction. When locking a database item, it's given the value 1 for lock and 0 for unlocked. Thus, with this kind of a scenario, meaning that a database transaction can lock a database item infinitely without releasing it for use with other transactions. Now that's where the whole debacle with the binary lock came in. And that's why the shared exclusive locks were basically brought in so that you could be able to distinguish between read and write. Now, with a binary lock, it didn't matter whether you're reading or you're writing. It will just lock. If you're reading, like let's say, for example, you're reading an item in a database, and then you're using binary lock, it locks. Which one has more exclusive rights between a read and a write operation? And remember, in the previous lessons, when we had talked about it, I said that write operations are usually given first precedence. Write operations are really important because with write operation, it means that you're changing that database item. Hence, when you're having a write operation, it means that you need to have exclusive access to that database item. Now, with a binary lock, it never distinguished between read or write. Whether you're reading or you're writing, it just gave you a lock. It just locked that database item for you. And that's why sometimes you would find that some databases were in a consistent state of deadlock. What do I mean by consistent state? Whereby we have cyclic redundancy. Have you seen like a cyclic redundancy? Cyclic redundancy meaning that you have a database here. You have a transaction. Then you have another transaction. You have another transaction. Okay. So we can call this, transaction 1. We'll call this transaction T1, and then you can call this T2. Now, T1 has a resource that T2 needs. So what will happen is that there'll be a consistent kind of a back and forth between these two. And it should be in such a way that you do not, in a database, you do not want to have this cycle. Because if you have 1,000 transactions and then the database item is shared between only 2 transactions, how will the rest of 998 transactions be able to perform? So we do not want to have this aspect of cyclic redundancy, which further led to having deadlocks. And deadlocks, we can say a deadlock is a situation whereby a deadlock is a scenario where a transaction waits for a locked resource indefinitely. Deadlock is a scenario whereby, and I believe you know deadlocks, you're waiting for a resource, but that resource is not coming. So you cannot, hence that transaction cannot continue. And continue with its execution till the resource is freed. That's where we are having the issues with deadlocks, and that's why binary locks were not the best option to use. Okay, they usually use to ensure that if I'm reading or writing, it means that I have exclusive right to that database item. But with binary locks, it usually eroded the aspect of concurrency. You know, concurrency ensures that more than one transaction can be able to access that database item and do work on it. So that's why we needed to have concurrency. And in systems that you're having today, network-based systems, cloud systems, they all have an aspect of concurrency. So binary locks were not the best thing to use while looking at were not the best thing to use while looking at locking mechanisms. So that's what we had. Now, what else do you have? I'm trying to save this presentation. So I have to check if it's already saved in a folder. Yeah. Okay, it's there. Now, another thing. Okay. Another thing which we wanted to look with binary lock is that so you had to force a transaction to wait. Okay, you had to force a transaction in a binary lock. You had to force a transaction to wait for that other transaction to finish up with the lock so that it can it can be able to keep up with this number of locks. And still, even with the binary lock, remember I said that you used to have a lock manager, and a lock manager was found for both exclusive shared and binary locks. So to keep track and access of the locks. So when a binary lock, so how does a binary lock? So let me finish up with the binary lock first of all. So let me clear this. So binary lock, how did the binary lock operate? How did the binary lock operate? Now remember that this locking is managed by the lock manager in a database. So how did it operate? First of all, for it to operate, it had to have it had to have like a series of 4 steps. The first step is that a transaction issues the operation lock X before any read item X or write item X are performed. So what it means is that when you're performing a lock operation, the transaction has to, first of all, 1, issue a lock operation before either reading or writing a data item. That's the first thing you had to do, issue a lock operation, or to some extent, operation lock before any read. And then the second one would be that's the first thing, issue a lock operation before either reading or writing. 2. Another one would be a transaction must issue the operation unlock. It must issue the operation unlock. The transaction must issue the operation unlock after completing all the read and write operations. So if you wanted to do a transaction, first of all, you have to issue a lock operation on that item, and then you must issue an unlock after you've completely finished with it. The third one is that a transaction will not issue a lock operation if it already holds. So a transaction cannot issue a lock operation if it already holds. If it already holds the lock on item X. Let's say we call it item X. All of these we are referring to a particular item. So if you're already having a lock, why issue a lock operation? So there's no need. So what does that mean? If I had a read lock, meaning that I will still have a write lock. So there's no need of me issuing a read lock and then I come and issue a write lock. So if I issue a lock, it's either I've done it for read or write, and then I must unlock it. And the other one, the last one, is that you cannot issue, a transaction can't issue lock on an item unless it holds a lock on that item. These three are the basic ones. These three are normal. I cannot issue a lock if I do not need, if I don't have a lock. I cannot unlock if I don't have a lock. But the first two, now let's look at the first two. Issue a lock operation before either read or write, and issue operation unlock after completing all the read and write operations. Now, this is why I said there was a very big issue. This issue brought about the issue of deadlocks. And these two even brought about the issue of not having concurrency. We cannot have concurrency if I just read, if I'm either reading or writing, you are giving me the lock to everything. There will be no way that database or that database management system is able to implement concurrency control. So that's why we had that aspect of binary locks. And with binary locks, it ensured that no two transactions, sure that no two transactions can concurrently access the same data. That one you have to be sure, because it's a binary lock. If I'm reading or writing, you're giving me a lock, meaning that if I'm only reading, transaction A is reading, it is given a lock, regardless if it's not writing. Transaction B, if it wants to write on this same data item, it cannot write until transaction A releases the lock on that data item. And that's where the binary lock was a bit of a disappointment. There was no concurrency in that, and there was an issue of deadlocks. Deadlocks whereby you would wait indefinitely for an item to be released by that aspect. Now, that's when they came and decided, why don't we have the shared exclusive lock? Okay. Now, with shared exclusive lock, as I said earlier, we had the shared exclusive lock. And the shared exclusive, I said shared is where you have read, and exclusive is where you have write. Now, if you have those two, shared exclusive lock, it means that you could implement concurrency concurrency could be implemented easily. Why do I say that? Could be implemented easily. Why do I say that? I say that because if you wanted to only read an item, there was no need for you to lock that item indefinitely. There was no need. Like, for example, the binary lock. The binary lock, whether you're reading it locked and another transaction could not use that data item. But with shared exclusively, shared, if you're given a shared lock, it means that I can read while another transaction can be able to read. Okay? To access the data item if they all access X for reading purposes. Now, that is only for reading. If reading is quite easy. With reading, several transactions can access the same data item if and only if all of them are reading that data item. If you're reading, if A is reading, B is reading, C is reading, D, nyote mtasoma vizuri. Because reading, you're not changing. But if it's writing, then only one transaction can be given an exclusive lock to that particular data item. Only one transaction can be given a lock to that particular item. So it means that it must have exclusive access. That's why it's called exclusive. Exclusive meaning that no one can be able to use that data item as you're using it. Now, there are three operations involved here. There are three. Operations involved here, which are read X, write X, and lock X. So those are the three operations. You can have read, write, and unlock X. Read lock, actually it's read lock. Sorry, it's read lock. So you have those read lock, write lock, and unlock X. So those are the three. So shared lock means that you only have read lock. Write lock means that you have exclusive lock. When unlock X means that you have unlocked that data item. Okay. So it means that one thing with this kind of a scenario of locking is that the database management system was able to distinguish the type of lock that it has been offered to a certain data item. Unlike in the binary lock, there was no distinction. If it's locked, whether you're reading or writing. But now here, if you're reading, it's called a shared lock, and it will be denoted in the DBMS in the lock manager that this transaction and this transaction all have a shared lock on this data item X, and hence you can be able to, other transaction can be able to read. Now, if it's exclusive, it means that this transaction is given exclusive access to that data item, and hence other transactions cannot be able to access that data item. Why? So that you could not have issues of having phantom reads or dirty updates and everything like that. Okay. Now, one thing with shared lock, it means that shared lock you can only read, but you cannot update. Now, with exclusive lock, it means that you can read and update. That's one thing we also have to denote here. That with shared lock, you can only read, not update. While with exclusive, you can both read and update. That's something we have to be very clear with. So with exclusive, you can read and update. So that's why there's a need to lock that shared exclusive lock. You cannot do that with a shared lock only. Now, what happens if, let's say, you have a scenario? You have a scenario whereby if it's shared lock and you want to access it, that database item with the shared lock, if another transaction has it on a shared lock, it means that if you're also doing a read, you can also be able to read that data item. Now, it comes an issue when you want to issue an exclusive lock. With an exclusive lock, it means that that data item must be unlocked. If it's locked, be it even Gridlock, and you want to have an exclusive lock, you cannot be able to access that data item. Why? You will be given an exclusive lock, and then you change that data item while still that other person is still using that data item, and that is wrong. So when you're having a read lock means that you can, here's now where the whole deal comes in. Read lock means that several transactions can be able to access that data item at the same time. That is concurrency. Write lock, exclusive lock, means that that data item has exclusive access to that data item for a specified period of time. Specified period of time for which to access that data item, after which the lock manager has to ensure that that data item is released for access by other data elements. I believe you will denote that. You will note that down somewhere. Okay? You'll note that down somewhere, what I've just said. Whereby, if you're having a read lock ensures current access for reading operations. While exclusive lock ensures another feature which we are talking about, security during the transaction. Meaning that if you want to access a write lock item X, meaning that you're trying to access an item that has already been given exclusive lock to another transaction, meaning that if you want to access a write lock access, you have to wait for the transaction locking it finish so that it can unlock, and then your transaction can access it. Now you see, now that's where the whole difference with the binary lock comes in. Binary lock, it didn't matter whether you're reading or writing, it's locked and you had to wait indefinitely. There was no given mechanism to time that wait. But with shared exclusive lock, if it's read, you can all access. If it's write, it means you have to wait for a certain period of time for that transaction to finish executing. It releases the lock, and then now you can be able to access that transaction. Okay. So meaning that this one, when you have to wait, it means that you, for lock to efficient, this wait is called a wait state. This wait is called a wait state. Wait state, whereby you have to wait, and it's usually timed. It's usually timed by that lock manager, so that if it's not, if that waiting time supersedes, depending on the way the transaction is performing, it can either release or add more time to that transaction which is performing, and then you'll have to wait a cyclic another amount of time. Okay. Now that's what we have with the binary lock, and then we have I've talked about the read and the write. Now the unlock. If a transaction finishes with that data item, it must unlock. So the unlock is used. Unlock X is used to unlock a data item once. To unlock a data item once the operation on it has finished. The operation's been done on it. So we have that as the locking mechanism. We have that as the locking mechanism. And it's quite simple as that. Quite simple as that now. So that is how they implemented. And I've talked about how we implemented the binary lock. You're either read or write, you're given a binary lock. It had its issues. Shared exclusive, where shared had a read, exclusive had a write, but you also had to have an unlock. Then you had to add a wait state for transaction locking for it to finish so that you can unlock that other transactions. Now let us go to the last one, which I saw as a really good thing to talk about. Was talking about the two-phase locking. Two-phase locking, or what usually called two-phase locking, 2PL. Two-phase locking. So let's talk about that. This is also another form. We have talked about binary, shared exclusive, and then we have the two-phase. 2PL locking. Just clear this. This is the other one. Two-phase locking. Two-phase locking. Now, two-phase locking. They come, first of all, you have to know what is two-phase locking. And two-phase locking is there just to ensure serializability. It's there to ensure serializability. So serializability meaning that one thing is that a transaction can be able to follow in a certain kind of a schedule to ensure that we have no deadlocks around. So what do we mean by serializability? We can say that a transaction is said to follow the two-phase locking if all operations precede the first, which let me just copy this here. That's two-phase locking. So that's two-phase locking. Meaning that a transaction is said to follow the two-phase locking protocol, basic 2PL, if all locking operations, that's read lock, look at that, read lock, write lock, precede the first unlock. Precede the first unlock operation in the transaction. Precede the first operation in the transaction. Such a transaction can be divided into phases. An expanding or growing phase during which new lock on items can be acquired but none can be released, and a shrinking phase during which existing locks can be released but no new locks can be acquired. So that's a two-phase locking. Serializability, read lock. After unlock, of all locking operations proceed, go like read, I write, read, write, read, write, read, write. Then you have two-phase locking, and you have expanding. Expanding where it means new locks on items can be acquired but none can be released, and a shrinking phase which ensures existing locks can be released but no new locks can be acquired. We have that aspect of two-phase locking. I don't know if I'll be able to share this. Okay. Let me try and get this thing, if I'll be able to get this. Mhm. Snapshot. Okay, let's see. Let's see this. Just draw. I cannot be able to close that table. Okay, no matter, no need for it. I will share these notes with you. And there's a note which I'm trying to look at, which is the 2PL, the basic 2PL. Oh, I have an example here. Let me share my screen. So, yeah. Here. So 2PL. Now, for example, we have this example of 2PL, which I've talked about. 2PL, and if all locking operations precede the first unlock operation instruction, it has those two phases, growing phase and shrinking phase, where locks are released. We have those two. Now, one thing we have to ensure, like, for example, T1 follows 2PL protocol. This transaction one, you see, all its locks are acquired before it releases any of them. So we have read lock, write lock, read lock X, read left, then write lock, then unlock, then read Y, then. Now look, T2 does not. It releases its locks on X and then goes on to later to acquire lock on Y. So where does it release? So this is the first one. Second, write lock. Now you see, it releases. So T1 follows 2PL, T2 does not follow 2PL. That's one thing. Now, any schedule of two-phase transaction is conflict serializable. Lost update can't happen in 2PL. That's one thing, which, because you're reading and then you read lock, then you commit. It's trying to show cannot acquire write lock on X. T2 has read lock X at the same time, because read and write, then write X. Okay. So there'll be an issue with that uncommitted dependency and all that. So let's leave these aspects of uncommitted. These are things which I talked about serializability. It's talking about 2PL. Now with 2PL, it means that you have to have that phase. You have to have that phase of that aspect of read and write. Okay. Have to have that phase of read and write. You have to have that serializable phase going to one another and doing all that you can be able to do with that aspect. Now, one thing we have to ensure is that with 2PL, with two-phase locking, there's an aspect of deadlocks. Deadlocks can be happening if you're having an aspect of 2PL. Like, for example, let me share this screen. This is an example of where you'll have deadlock, where you have read item, read lock, read item Y, read lock, read item X, write locks, wait. Write lock Y, wait. It will wait because T1 wants to have a lock on item X, which has already been locked, and T2 wishes to have a lock on item Y, which is already locked by this. So we'll have deadlocks, okay? Because that's the thing. Here, you're trying to write an aspect which you have not locked. The same with T1 is trying to write an aspect X which does not locked, while T2 is trying to write an aspect Y which does not lock. So that is what we call serializable. serializable, when you have that aspect of serializability, serializable schedules in everything that we have. Now we have two variations of 2PL, two-phase locking. We have conservative, then you have to have the strict. So conservative is a way of avoiding deadlocks, okay? So the conservative requires a transaction to lock all the data items it needs in advance. If at least one of the required data items cannot be obtained, then none of the items are locked. Meaning that with conservative, if I want to have a lock, a write lock, it means that I should have a read lock and a read item on this X. Now here, this is an example of a conservative kind of a scenario. Conservative. It ensures that if you're going to implement it, then it means that if I'm going to read lock item Y, then it means I should also have a write lock. Sorry about that. This is not an example of a conservative. This is an example of a normal 2PL. Normal 2PL does not have that guarantee. With guarantee meaning that with normal 2PL, the way it is, normal 2PL, if I may share that thing, normal 2PL is that you have to read lock, then read item, and then you can either write or do anything. There's no need for that. That's normal 2PL. But now if you come to conservative 2PL, okay, conservative 2PL. Let me finish first with normal 2PL, the way I've seen it. So the way you have seen it in normal 2PL, you have read lock, then read item, and then you have write item. Write item. But now this is the way it should be. But in normal 2PL, it's not a guarantee that you'll read item X, read lock item X, read item X, and then you write item X. No. With normal 2PL, as you can see in that example which I showed, they have item X and then they go to item Y. But now with conservative 2PL, it means that if you read lock, read item, and write item for the same data item. That is, if it's X, it is X all through, till you're through. If it's X all through. Meaning that you have to acquire these locks, acquire the locks in advance. You have to acquire the locks in advance. If I want to read item Y, if I want to write item Y, then it means I have to read lock, read item Y in advance. If I want item X, I'll have to read lock, read item X in advance. And then you have the strict 2PL. Strict 2PL. Strict 2PL, strict 2PL means that it's basically a conservative. It's basically conservative 2PL with restrictions. Restrictions that a transaction can neither read. The transactions can neither read nor write until as aborted. Neither a transaction, the transactions can neither read or write. That's where the whole thing comes now. Strict 2PL is basically conservative 2PL, but with tradition that transactions can neither read nor write an item X until the last transaction that throat X has committed or aborted. Okay, has committed or aborted. Now, here the difference between conservative 2PL and strict 2PL comes in. 2PL means you can acquire. Yeah, you can acquire the lock even before the preceding transaction finishes, commits or aborts. That's why there was no issue of deadlocks. There were no deadlocks here. No deadlocks. That was the conservative 2PL, the normal 2PL. So we have talked about, we have started from the first ones, the binary, and then you come to shared exclusive, and then you have come to two-phase locking. Two-phase locking, you have read lock, write lock. That's what is two-phase locking. So read lock, write item, write item. Okay, read lock item X, read item X, read lock. You know, when you're having a read lock, it means that you want to use that item. And then you go ahead and use it. Now, with conservative 2PL, there was no issue of, there was no precedence whereby that item should have finished. Okay, so that's the thing. The need for it to, even before the preceding transaction commits or aborts, then there was no deadlock. Strict 2PL, it means that you had to have it commit or aborted. That was where the major difference for these two examples came about. Now, that is what I wanted us to discuss today. If I share this handout with the people, let me check. Not shared. I'll share with you this chapter 13. It's all about what we are going to discuss today. Then I'll also share the PowerPoint presentation, and then I will share this this video with you people so that you can be able to look at it and continue with it. Now, the next thing that we shall be looking at after I've looked at this two-phase locking is time-stamp-based protocols, but I will be able to give you this link so that you can be able to access videos. So thank you for your time, and we shall see each other once again. Okay, here's the end video.